Question 2 is about group 7 chemistry. They are called halogens. Halogen comes from a Greek word. It means electron giver. Okay? Is it electron giver? No. Electron receiver. Electron receiver. It likes to receive electron, yeah? Anyway, why the elements that have similar chemical properties? When they are in the same group, they have similar chemical property. Not just group 7. Group 1, all the group 1 metals have similar chemical property as well, because chemical property is to do with the number of outer shell electrons. Same number of outermost shell electrons. I don't really like the word outermost shell electrons. I prefer the words valence electrons more, but it just depends on your books and how you learn it. They all refer to the same thing. Yeah. A redox reaction happens when you bubble chlorine gas. Usually we have used aqueous, but here they use the bubble chlorine gas through the iodide. Iodide, remember, is a very good reducing agent. So you learn Ki as good reducing agent. Reducing agent means itself get oxidized. I'm going to talk about oxidation number. So I'm pretty sure that the oxidation number syllabus has been taken out from the current O-level syllabus. But this was back in 2018. Things might have changed from year to year. That's why you always have to follow the latest syllabus to see what you're expected to know. I would still expect most schools to teach oxidation number regardless, because it's an important concept that you can use as correct chemistry, unless the question specifically asks you in terms of electrons or in terms of something else. Like this one, they say to explain oxidation take place in this reaction. They don't specify use electron or use oxidation number. So just because your school doesn't teach you or like the syllabus doesn't say you need to know, but oxidation number is perfectly legit and you will never be penalized for showing correct chemistry if the question doesn't specify that you have to use a certain definition for it, okay? So this is iodine as an element. The oxidation state of the atom is going to be 0. Same as chlorine. As an element, the oxidation state of the atom. So oxidation state is defined as the charge that an atom will have if that atom in that compound or that molecule does form an ion. Okay, so here the oxidation state of an ion such as Cl minus is just going to be the charge of the ion, because it's just one species, it's -1 charge, so it's just -1. Same there. Okay, chlorine 0 to chlorine -1, there is a decrease in oxidation number, so that is your reduction. How can you go from chlorine 0 to chlorine -1? Well, if you write your half equation correctly, it has to gain electrons, because no charge, gain -2 charge, you will get 2 Cl minus. That is your half equation. That is gain of electrons. Gain of electron is reduction. So it's the same concept in terms of oxidation number or in terms of electrons. Alright, so what do you observe? Well, the color of chlorine gas is pale green. So the pale green, something like greenish yellow, kind of near colorless, but because you're using gas, so there's pure CO2, that's why the color is more intense. Yeah, pale green color of CO2 gas will fade because I minus is colorless. Okay, it's soluble. Yeah, and brown solution of I2 aqueous will form. So aqueous iodine means iodine dissolved in water is a mixture. Iodine exists as a gray solid. It's like a gray color solid at room temperature and pressure. Yeah. Why oxidation takes place? Well, we talked about it just now. So either you write half equation and show it, such as 2I minus going to I2 plus 2 electrons. That means the I minus must have lost electrons. Okay. So the I minus loses electrons or lost electrons. Loss of electrons is oxidation. Or you can talk about the oxidation state or oxidation number or oxidation state of iodine, because oxidation state of the atom increases from -1 in I minus to 0 in I2. So I provide two alternatives there. What I'm going to do for the next one is I'm just going to use one of them. Obviously, if you use the other in terms of electrons, you're more than correct if you get the correct chemistry as well, yeah? So the oxidation state of chlorine decreases from 0 in Cl2 to -1 in Cl minus, because they did not specify you have to use in terms of electrons or in terms of oxidation number. So I've chosen to use oxidation number here, but you could have chosen to write these half equations, and you will show the again electron, which is reduction. All right. Describe a chemical test for chlorine gas, not a but the. This is your paper 3 qualitative analysis, but in your theory paper, which you're expected to know the test anyway, for any gases, all right, you're not given a table with the result. You should have known that. Okay, so you can pass the gas through moist, or you talk about damp. It's an acidic gas, okay? It's an acidic gas. So we want blue litmus paper. So, or if you have a test tube with this gas being produced, you just put the moist or the damp blue litmus paper on top of it, and you will see the blue litmus paper. It will turn red because it's acidic gas, and then eventually it will get bleach because chlorine can bleach, and eventually gets bleach. So bleach means it will turn red first, and then it will turn entirely white. Construct the Ionic equation for this thing. This is a chloride, this is a bromine, this is chlorine, this is magnesium bromide. Mg2 plus Br minus times 2. This is Mg2 plus Cl minus twice. Aqueous and aqueous, Mg2 plus and Mg2 plus cancel. They are both soluble in solution. They are what we call spectator ions, so you can read that up if you're unsure what I'm talking about. Chlorine plus Br minus give you Cl minus plus Br2. Balance the equation just like that. So chlorine, bromine, and iodine, better. So going up to group 17, these are better oxidizing agent. On the other hand, Cl minus, Br minus, and I minus, this become better reducing agent. So when you have that, you are trying to react chloride with bromine. So bromine is below chlorine in this series. So bromine is a weaker oxidizing agent. Bromine is a weaker oxidizing agent than chlorine. Therefore, bromine cannot oxidize chloride to chlorine. So the word really is very tricky. So we're talking about the halogen being oxidizing agent. Therefore, you cannot form the other halogen from the halide itself. Next bit, how do you test for iodide ion? This is in your paper 3. You are obviously given the table in paper 3, but do not forget, they can ask you anything in theory paper, including paper 1 and paper 2, where you are not given that table. My strongest advice is, please know your analytical chemistry table, very well, because it's actually part of your syllabus. Okay, so all iodides are soluble. This is solubility of salt. Yeah? All iodides are soluble, except for silver iodide and lead 2 iodide. That's why we use silver nitrate. Add AgNO3 aqueous to the solution containing I minus aqueous. Soluble, insoluble. What you're going to get is, you're going to get yellow precipitate. Yellow precipitate forms. I did say lead 2 nitrate are possible as well. So the other one is you can add lead 2 nitrate. This is silver 1 nitrate, so it's Ag plus NO3 minus. Lead 2 nitrate, Pb2 plus. Therefore, you need 2 of the nitrate to get the formula correct. Formula again is the very basic fundamental stuff required in O level. Yeah? then you get yellow precipitate as well. Okay, there's alternative results. The other thing is, I must say, is you should probably write down the full precipitate in words, because you're not in practical, you're not in paper 3. So in theory, you have to write down precipitate. Yeah. Next bit, ammonium iodide reacts with aqueous bromine. Aqueous and aqueous. They want ionic, so you gotta think about spectator ion. I'm sure you've heard about this term, so make sure you know what you're talking about. Yeah. Ammonium iodide plus Br2. You know this is a stronger oxidizing agent than iodine, so this will oxidize iodide to iodine, and you will get NH4Br. In fact, you get 2 of it and 2 of it. This will be aqueous, 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 and aqueous. These are halogens. They do not dissociate. These are all ammonium salts are soluble, so that's going to give you 2 NH4 plus and 2 Br minus. 2 NH4 plus 2 I minus. Spectator ions are the NH4 plus. So altogether you're going to get like that. Sorry, 2 Br minus. Maybe I should write the I2 first to be consistent. 2 Br minus. Do not forget stat symbols. Aqueous, 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 aqueous. Why do I not write liquid or solid? Because they give me aqueous. Okay, I'm in water. Alright, balance in terms of atoms, balance in terms of charges. Lead is a metal, silver is a metal, yeah? So next bit is why do we not want to use CFC, alright? So why CFC is bad? So CFC can destroy ozone because they can react with ozone, and we need ozone to protect us from the direct UV radiation of the sun. They can cause skin cancer, yeah? So what happened is on the atmosphere, and then why this is a problem. So you want to say why this is a problem. So when ozone layer gets depleted, so depletion or depleted is basically similar idea as destroyed, so slowly getting lesser and lesser. More direct ultraviolet radiation from the sun can reach Earth's surface, therefore can cause skin cancer. So it's quite a big thing in Australia, where there's quite a big hole in the ozone layer in Australia compared to the rest of the world. Okay, next bit, complete the table. They want you to estimate the boiling point of bromine. Okay, so based on this, you should be able to see that they increase, they become more positive. But what do you know? You know Br2. You see, what do you know? Bromine is a liquid at room temperature and pressure. In the whole of the periodic table, there are only 2 liquid elements, one of which is bromine, the other one is mercury. Mercury is a liquid metal, bromine is a liquid molecule. Okay, so RTP is 25 degrees Celsius. So whatever you do, do not put down 24, do not put down 25, because if you put that down, bromine will be a gas at room temperature and pressure, and it doesn't make sense. Okay, it's a liquid at room temperature and pressure. It's roughly around I don't have it on top of my head, but I would say like 70-80 degrees Celsius. So somewhere you put down a value somewhere around there, I'm sure it'll be alright. So if I put down 70 or 80 degrees Celsius, will be okay. Although it might differ from the actual value, you see, except that you shouldn't put down 25 or 20. Alright, next bit, the density of liquid chlorine. So you see down this group 17, the density actually increased. Okay, we can work out roughly how much they increased by. 4.93 minus 3.12 is going to be an increase of roughly 1.81. 6.35 minus 4.93 is roughly an increase of 1.42. So if you think about roughly the same kind of increase here, so maybe between 1.4 and 1.8, So if you think about maybe 1.8, let's say. So how you get it is you can 3.8. It must be lower because we know it increased, right? Down group 2. So 3.12 minus 1.8. It's going to give you something like 1.32 roughly, you know. It's an estimate. So I'm just estimating it based on what I see here. It increased down the group by roughly around the same amount, 1.8 or 1.7 or 1.6, yeah? You want to think about the color of S13. So you see it gets darker. The intensity gets darker, right? So this is already gray-black. I can probably think about black as the only possibility. What else is darker than gray-black? Black, you know? So there we have a line there. Perhaps I just write it down there. Why chlorine is used in water treatment? So it can kill microorganisms. So microbes or bacteria or harmful microorganisms. Okay, next bit, they want an ionic equation. So here you have chlorine reacts with aqueous. So this is K plus aqueous, I minus aqueous. You get aqueous potassium chloride. So this is K plus aqueous, Cl minus aqueous. Even before I start writing the full balance equation, think about the K plus aqueous and K plus aqueous. These are what we call spectator ions. You do not need them in the ionic equation. Chlorine plus I minus give you Cl minus plus I2. You have 2 chlorine atoms. You have 1 chlorine atom. 2 there. You have 2 iodine atoms. You have 1 iodine atom. 2 there. Atoms are balanced. Check the charges. No charge. 2 times minus 1 is minus 2. 2 times minus 1 is minus 2. No charge. The charges are balanced. Okay. So you should know that chlorine, bromine, iodine. So this is oxidizing, better oxidizing agent. And then chloride, bromide, iodide. So these are the highlight. Down that series is better reducing agent. So iodine is all the way down there. So iodine is a weaker oxidizing agent than chlorine. So iodine cannot oxidize chloride to chlorine. So if we react, chlorine will go to chloride. Chloride will go to chlorine too, like that. But iodine is a weaker oxidizing agent. This is minus 1. You want to go to chlorine 0. There is oxidation. Iodine is a weaker. Iodine refers to I2. It's not iodide. Iodide is I minus, yeah? So iodine is a weaker oxidizing agent than Cl2. Therefore, it cannot oxidize. It cannot oxidize Cl minus to Cl2. Alright?